Okay, so let's start. So welcome everyone. Good evening. So this is our live session for week 10, and today we will be discussing some problems which are related to application of integration. Last week we discussed a problem where we were finding area of curves bounded by we were finding area below the curve bound above the x-axis like this. So we were finding area of some bounded regions using the integrations. So this week, mostly the problem will be based on to finding volume of certain solids. Okay, so not every kind of solids, but there will be very symmetric or you can say like if you know the area of the cross section and you integrate that area of the cross section over the entire interval, you will get the volume of your solid, and this is called a slicing method. So the problems will be based on the slice method to find the volume of solids. So the and a particular case of the slice method is called a disk method or a washer method, where you will be finding area volume of the solid generated by a revolution of a plane region about some fixed axis, right? So it's like you have a closed and bounded region in the plane, and you are rotating that region around about some axis or some line, straight line. Okay, so the solids generated by this rotation of this region is called the solid of revolution. Okay, and we will be finding the volume of that particular solid of revolution. For that we will use the same slice method, but because we are revolving or rotating a plane, a part of the plane or a bounded region about some axis, that means if you take the cross sections about the planes which are perpendicular to these lines about which you are rotating your region, then you will see that you will get some slice whose radius is given by function. Okay, and depending on that function, the slices they become disk. Okay, so the radius of the disk will be varying according to the function, but it will be a disk. And so so the slices are disk, and for each slice we know the area of the disk, right? We know area of circle or area of disk or the region bounded by a circle, that is pi radius square. And using this formula we get the area of the each slice, and then we will integrate that particular area across the all possibility of that cross section, right? So I'll explain all these things through examples. So let's see our first problem. Okay, so here we see that we have to find the area of a solid. Okay, and solid is given with this description that its base is the region bounded by some curve. Okay, so what is that curve? It is y equal to 2 under root sine x. Okay, so so for example, it can be a line like this. So you may be asked to find, okay, in different case, not here, maybe this curve may be very simple like this, is maybe a straight line, and then there will be a region like this, maybe triangular region. And okay, so this region is bounded by three lines. So this is y equal to x, you can say okay 1, this you can say y equal to 1, and then this line x-axis or y-axis, this is just the line which says that your x is 0, right? Y-axis, on the y-axis your x coordinate is always 0, so this is line x equal to 0. So this is a triangular region bounded by three different lines, and you may be asked to find the volume of a solid which you get after you revolve this region about some axis, right? So this axis can be anything. Okay, so for example, it can be y-axis. So if you revolve it around y-axis, you get a solid. So what kind of solid you get? Let me draw some picture that may not be very perfect, but still okay. So you can see that this is line y equal to x. That means this is point 1 comma 1, and then you will have point 1 comma minus 1, or minus 1 comma 1, 1 comma 1, and like this. Because you are rotating this particular part, you will get a cone, right? The solid of revolution in this particular case will be like this. It will be a cone. It, if you revolve the region about y-axis, like this. Now, if you want to find the volume of this particular region, what do? You take slices. Okay, so many slices, like from any line which is some y equal to constant. This constant can be anything, but between 0 and 1, because this is line where y is 0, this is line where y equal to 1, and in between we can take lots of slices. Now, on each slice, you can see that you have a small disk, like this, because the cross section looks like this, right? Because this region is generated by revolution of this particular region about y-axis. So each cross section is a disk. Now, for this disk, what is the radius? So radius is this particular line, right? This distance is the radius of this disk. Now, what should be this distance? You can see that at this particular point, if this is your point on the line x comma y, that means this distance is x, and this vertical distance is y, right? So that means the vertical a radius of this disk is this horizontal distance, which is a function of x, right? And so the radius is y is equal to x. Okay, radius is x, but that is a function of y. Okay, so this line y equal to x, we can treat it both as a function of x or function of y. Okay, it depends on which variable you choose as independent variable. So here the radius is x. Okay, so radius is x unit, but that x depends on y, right? Because why we want to make y as independent variable, because you can see that the slices, they move along y-axis, right? So the y is an independent variable. You can take any slice, okay? And for each slice, so the area of the cross section is pi y square, right? It will be pi x square, but x is equal to y. And now you can integrate this thing from 0 to 1, okay? Because this is the area of disk, okay? Any disk which is the area of the cross section. And if you integrate such areas, integration means you are taking summation, okay? So you are computing area, and then you are adding those area across all possibilities where this y varies. So y varies from 0 to 1. So this kind of integral will give you the volume of this cone, okay? So this was a simple example, but in general, the situation can be very different. So in this particular case, in the first question, we have to find the volume of a solid whose cross section is already given. Okay, so here the cross section, so whenever we are revolving a particular region of the plane across some axis, then cross section will always be disk. Okay, so they will be either so they will be circular. Okay, the cross sections will always be circular, but here the cross section to us is given. Okay, so here the solid we are not getting it as a surface or as a solid of revolution. Okay, so we are not revolving any region here, but the cross section is already given. So cross section perpendicular to x axis, they are equilateral triangle. Okay, so we assume that there is a some curve, and that curve is given by this equation 2 under root sine x. Okay, so if you want, you can draw that curve also. We can draw some approximate curve. It's like at x equal to 0, sine 0 is 0, so y, so at x equal to 0 you are at the origin, and if you want, let's say, okay, x equal to pi. Okay, so here we have this point x equal to pi. So at pi, the y is also 0, and you can calculate some in between point pi by 2. Sine pi by 2, it will give you 2. So let's say this is your 2. Okay, so the this curve is like this. Some because these are smooth functions, right? They are differentiable continuous and differentiable function. So let's assume that this curve look like this. So this is y equal to the function of x. So this is your function of x. Okay. So it's given that there is a solid whose base is this. Okay, so this is the base of your solid, and it says that the cross section perpendicular to x-axis, they are equilateral triangle with bases running from the x-axis to the curve. Okay, so this is our x-axis, and when you take cross section of this particular solid about the plane which are perpendicular to x-axis, right? Like this, we have this yz plane, y, and then there is a third axis z, right? Because we are in three-dimensional space, and we want to find volume of a solid. So volume solid is a three dimensional. So when you take some plane which is perpendicular to x-axis, so there is a plane. You can assume that it is like this plane in the three dimension. So you always get some equilateral triangles, and the equilateral triangle has its base between the x-axis and the curve. That means this must be this particular portion from here to here. This must be base of the equilateral triangle. Okay, that means in the plane there is equilateral triangle like this. Because of this equilateral triangle, this is not on the plane, on the xy plane. This is on the yz plane. Okay, so yz where, but x is some fixed. Okay, so yz plane where x is fixed, some constant. Okay, so here it may not look like equilateral triangle, but assume that all these sides are equal. Okay, so like this you get equilateral triangle. So whenever you hit some plane, let's say another plane like this, then again you get some triangle with this base and a equilateral triangle on the plane. Okay, like this. So now you want to find the volume of this solid. Okay, and on this each cross section you have a triangle. So if you find the area of triangle as a function of x, okay, so let's call this area of triangle to be ax as a function of x. Okay, that means we are taking this distance to be x, and at distance x, whatever equilateral triangle we are getting at particular cross section, we are calling area of that equilateral triangle to be ax. Okay, and now you integrate this ax with respect to x from 0 to pi. Okay, so that means you are adding all the areas of equilateral triangle, so that this in a way that this equilateral triangle varies from 0 to pi, right? At each value of x between 0 to pi, you have equilateral triangle, and if you add areas of all these equilateral triangle, that means you get your volume of your solid, right? So this is called a slice method. Okay, so the solid is given. The solid has its base like this, is bounded by x-axis and your curve, that is the base of the solid. And whenever you take a slice of your solid, so slice we are taking via a plane which is perpendicular to x-axis. Okay, so we are hitting or cutting your solid across the x-axis by this plane which are perpendicular to x-axis, and we are getting some triangle, equilateral triangle. Okay, and now we are adding areas of all these equilateral triangle. And for addition, because it's a continuous process, so instead of addition we are using the integration, because integration is just the addition in the limiting sense, right? The definition, you know how we define the integration using partitions and everything. So like this, the area of each slice, when you integrate it over the all possible limits, you get the volume of your solid. So this is the volume. So this is a illustration of the slice method. Yes, slice method. So so what is the slice method? Always find the area of slice Okay, so in a lot of time, this area of the slice will be easier to find, right? Like here, the slice was equilateral triangle. In the surface of revolution or solid of revolution, you get slice to be disk or annulus, right? Annulus means the whole disk, like this. You have a disk, and inside that there is a hole. This particular thing is called an annulus. Okay. So if you have such slice, then finding areas of such slice are very easy. So find the area of slice as a function of x or y, whatever your independent variable. Let's say that it is x, and then integrate over the all possible limits of x, right? Upper limit and lower limit. So that if your x varies between a and b, so you integrate between this limit, the area of the slice, and you get the volume. Okay. So in our case, this equilateral triangle. So how do we find the area of this equilateral triangle? Now that is the question, right? Because now we know how to find the volume. For the volume, we need area of this slice, which is a equilateral triangle. Okay. So we use the information given because this base, you can see that the base always lies between x-axis and the curve, this y equal to x, right? So this distance will give you the side of this base or the side of the triangle. Okay. So what will be side of this equilateral triangle? So what can be the side of the equilateral triangle? So anyone can tell me what is this particular distance? Okay, so the slice we are taking at distance x. So from x-axis, from y-axis, we are at a distance x, and then we are getting a slice. This will be our slice. And what is the side of each triangle? Side length of each side of this triangle, because this is equilateral triangle, and this base lies between the curve and the x-axis. That means the distance at, because at this point, this particular point is just x comma y, right? And this distance is equal to y. So if you are at a different distance, let's say this distance, if your x is this, then your new distance y is this, right? So like this, the length of the base of this triangle is varying, right? It varies as a function of x. Okay. So what is the side length of the side? Length of side of the equilateral triangle, this is just y, which is as a function of x, is just 2 under root sin x, right? So this is our base. Now what is the area of an equilateral triangle? What is the area of a equilateral triangle? So how do we find the area? Let's see. Okay, it's not difficult because we know area of any triangle is always base into height, right? So this is base, length of your base, and then you have to find the height. This particular distance is height, let's say. So height, so this angle must be 90, right? Okay. So if we know that the base has length y, that means this hypotenuse must be y, right? And because this is an equilateral triangle, what is this angle? This angle must be pi by 3, right? This is 60-degree angle. Okay. Now can we write this height as a function of y? You can see that this height must be y sine theta. Sine this theta is pi by 3. Okay, so this is the height, right? This length is y sine pi by 3, and this particular length is y cos pi by 3. Okay. And that's how we are gonna calculate the area of the triangle. So what is the area? Is half into base, which is y, and into height. What is the height? Is y sine pi by 3. Okay, that means what is our ax as a function of x is half. Now we have a y square, so y square means we have 4 times sine x, right? And now sine pi by 3. So what is sine pi by 3? It is root 3 by 2. That means the area must be root 3 sine x. Okay. Now it's not difficult to find the volume. Okay. So what is the integration of sine x? It is cos x with a negative sign, and we have to put upper and lower limits. So root 3. So when you put cos pi, you get a minus 1. So it will become plus 1. And then minus minus plus, again a plus 1, right? That means it is 2 root 3. So that's how we have find the volume. So are there any questions? So let me know if you have any questions. For now, let's move to the next problem. Okay. So here you will see we will be finding volume of a solid which we get after we revolve a region about some axis, right? This is such a problem. Okay. So here you can see that we have a region D. So there is this region, we are calling it D, and this region is bounded by some curves and lines. Okay, so let's see what are those lines and curves. Okay, so we will not be drawing actual curve. It will be something we will see. Okay, so this region is in the first quadrant. So we already get two lines. That means these are x-axis and y-axis, and the solid must be in the first quadrant. Okay, so what is the line x equal to 0? So line x equal to 0 is means the y-axis. Okay, so this is the line x equal to 0, and then we have a line which is y equal to 1. Okay, so this is let's say the line y equal to 1. Okay, and then there is a curve. Okay, so now this curve can be anything. Let's draw some arbitrary curve like this. It doesn't matter. Okay, so let's say this is our curve. So this we can write this curve as a function of y also, right? It's better to write it as a function of y. Why? Because we are again revolving this region about y-axis. Because we are revolving region about y-axis, that means the slices we are taking, they are perpendicular to y-axis. Okay, so this is our region D, and now we are revolving this region about y-axis. Okay, so if you revolve that region about y-axis, then you get some solid. Let's draw this solid here also. Okay, so it will be like this. Okay, now you can see that whenever you take some plane which is perpendicular to y-axis, okay, so always take slices perpendicular to axis about which you are rotating your region. So take any plane. So on two dimension it will look like a line, just, but it's a plane, right? Because there is a z axis also, so it is a plane. And on this plane you will be getting some disk, right? It is like this. Okay, and now if this is our slice, and if you find the area of this slice, then after integrating this you will get the area of, or the volume of your solid. Okay, so what is the area of this slice? Okay, so here in this case the slice is a disk. Okay, so let's write that in this case the slice is a disk. Okay, slice is a disk, and the disk, this disk has the radius. How much is the radius? This is the radius, right? The distance from the y-axis, this x, is a disk with radius x. Okay, so it's x unit, and therefore what is the area of this slice? Ax. This area is just pi x square. Okay, and now you know that the volume of the solid. So what is the volume? Is this integral? You integrate your area and take the limits. Okay, so now you have to you see that because we are taking slices about or the perpendicular to y-axis, and these slices vary across y-axis, right? You can take slice at any level, so that means the slice varies from y, the slice varies from 0 to 1, right? Or let's say yes, so the slices varies from 0 to 1. Okay, you can see that this y equal to 1, this satisfy this equation. Okay. So we have to also find out what is x. So when y is 1, x is also 1. Okay, so at this point x is also 1. Okay, so this is the volume, but since your slices they vary across y-axis, right? Or you can say that your slice looks like a cylinder. Okay, because you can give this slice a small thickness. Okay, let's say this slice looks like this, and all thickness, right? Because we usually partition the interval so that there is a small thickness of this slice, and because the slice is across the y-axis, let's call this thickness to be dy. Okay, and then what is this area? This is area is pi x square. So the volume of this small slice is just pi x square times dy, right? And now we are integrating this that means we are adding a volume of each of these small slice and taking limit so that the thickness becomes 0. Okay, we are also taking this limit, so in the limiting process we are making the thickness to become 0, and in the limiting process instead of a summation we get an integral. Okay, that's why this dy this comes in the picture. And then we see that this y, this just varies here from 0 to 1. Okay, so the volume in this case is this integral 0 to 1 pi x square dy. Okay, but the because the integral is in the variable y, so independent variable is y, so we have to find this x square, right, as a function of y. So what is our curve? Our curve is already given to be x square 1 plus y square to whole square, right, is equal to 2y. So this was our curve given by this equation, and this will say that x square is equal to 2y divided by y square plus 1 to power 2. So this is x square, and hence what is the volume? So volume is this integral from 0 to 1 2y dy divided by 1 plus y square. So if you find this integral, you get your volume. Now how to find this integral? Okay, so how do we find this integral? We will use the method of substitution, right? Because we can see that this 1 plus y square in the denominator, if you differentiate it, you will get 2y, which is in the numerator. That means if you put 1 plus y square equal to some another variable, let's say t, and then you differentiate both sides, then you get that using chain rule that 2y dy, this differential is equal to dt. Okay, that means you can replace 1 plus y square by t, 2y dy is differential by dt, and in the process of this change of variable, you have to also find what are new limits of this integration, right? Because for y it was from 0 to 1, right? Y this varies from 0 to 1, and now we have to find where t varies, right? So 1 plus y square, this varies from 1 to 2, right? So the new limits of integration, they are from 1 to 2. So I think there was some problem with my internet, so that's why I got logged out. So I think I almost finished the second problem. Okay, so I will quickly go over again. Okay, okay, so I was doing this problem that you have to find the volume of this solid of revolution, and how are we getting this solid? We had some curve, and then we had this line y equal to 1 and this x-axis, and this thing we were rotating it about y-axis. Okay, so that we were getting this kind of solid of revolution, and then each slice we saw that each slice is a disk, right? And so each slice was a disk, some disk with radius equal to x. Okay, so what was the radius? So radius of this disk, let's call it r, and this is as a function of y. This radius was 2 2 times y divided by 1 plus y square divided by y square. Okay, this radius was just x. Okay, this distance from the y-axis. So radius was x, but because we want to write it as a function of y, so we are writing it like this. Okay, so because our equation says that x square is equal to 2y divided by 1 plus y square whole square. Okay, so that's why we have this radius. And now the area of the slice is just equal to, we know that the area of the slice must be pi r square, right? The radius square. Okay, so the area of the slice is pi times this rx radius, or it's a function of y actually, square. Let's call it ay. And now, what is the volume of solid? This is this integral of ay dy, where y varies from 0 to 1, right? So what is that? This is just integral 0 to 1 2y dy divided by 1 plus y square whole square, and then there is a pi also, right? This and now this integral you can easily find because you can change variable, right? We are writing 1 plus y square to be t, and then we have this differential 2y divided to be dt, and initially y was varying from 0 to 1, and that will just say that 1 plus y square, that is equal to t, that varies from 2 to 1. Okay, that's why this integral becomes just 1 to 2 pi, then 2y dy becomes dt, and then you have t square, right? So you can write pi outside. Now integral of 1 over t square is just minus 1 over t. Put upper and lower limits. That will give you minus half plus 1, and that is equal to pi by 2. Okay. So that's why pi by 2 was the volume. So the here third option is the correct option. Okay. So are there any questions? So let me know if there are any questions. Okay. So I think there are no questions. Let's move to the next problem. Okay, so this is our next problem. And again, we have a region D in the first quadrant. Okay, so this region is in the first quadrant. So let's try to approximate this region, how it look like. So the region in the first quadrant, that means the bound x-axis and y-axis, they will also be the boundary. And then there is a line, this line which is y equal to root 2. Okay, so the region is bounded above by the line. Okay, so it's bounded above by this line, and then there is a curve which is just this is curve 10x sec x, and this region bounded below by this curve. Let's draw this time this kind of curve. For okay, so John, I think previously there was some problem with my internet connection, so I did that question again, and the second problem, and the last time we were getting the answer to be half. So why I was getting that half? Because I missed this pi, right? And why I missed
Yes,
that
yes.
pi? Because the area is just pi r is radius square, right? Because the area contains a pi, and that I missed, so that's why I was getting only half. Okay, so this time the third problem is also looks very similar. You have to find again the volume of a solid which you get after you revolve your some region about this axis, some axis. Okay, and let's draw roughly how region this region looks like. So it can be anything, right? Let me draw it like this. So this is our region, and this is a curve y equal to 10x into sec x. Okay, and the region is bounded above by this line y equal to root 2, below by this curve, and then on the left by this axis which is y axis, right? And this is our region D, and then you are rotating it now. So you can see that now we are rotating it about a different axis, right? Initially we were rotating about y axis. Now we have to rotate it about y equal to root 2, this line. Okay, so our axis, the line of rotation is y equal to root 2. So in that case, solid which you get, it looks like something. So it will be symmetric about this line. This is only rough picture. Okay, so because the solid of revolution, it will be like, there is some problem with my writing device also. Okay, it will be like this, and this time you note that you have to take slice about a plane which is perpendicular to your axis. Okay, so the axis was this line y equal to root 2. This was our axis. And if you take perpendicular some about some plane which is perpendicular to this line, so it on two-dimensional plane it will just look like a line, but there is a whole plane, right? So you can write like this. So this is the whole plane, and on this particular plane you will find a disk. Now this will be our disk, the slice. Okay, it looks like this. Okay, so if we know to find the volume of this solid, if we know the area of this disk, then we can integrate that area between the possible limit. Okay, so you can see that this disk varies across all cross section. Okay, so from this particular line to the y-axis. Okay, so these will be the limits of cross section. So all possible cross section they lie from here to here. Okay, so this will be our lower limit and upper limit of the integration. And for finding the area of this disk, you have to find the area of the you have to find the radius of this disk. So what is the radius of the disk? So can you tell me? Anyone? This is the radius, right? We can draw it here like this, and this was our line y equal to root 2, and from the line this distance is our radius, right? So how much is this distance? Okay, so you can calculate this distance by first finding okay, so find this distance. You know that this whole distance from here to here, how much it is? It is root 2. So if you find out this particular distance, then you can subtract it from the root 2 to get the radius. Okay, so what is the radius of the disk? So note that in here your variable of integration is x-axis, right? Because your disk they vary from here to here, right? The lower limit to upper limit. So their these cross section, the disk they varies from the line x equal to 0 to x equal to how much? So when you get root 2, okay, so this is some point which has some x or some constant comma root 2. Okay, so what do you put as x input so that you get root 2 out of this curve, this line? So you can see that if you put x equal to pi by 4. So at pi by 4, 10x is 1. And sec x is just inverse of the cos. So that means 10 cos pi by 4, which is 1 by root 2. So this will be root 2, right? So at x equal to pi by 4, you get your root 2. Okay. So the radius of this disk, which is just equal to root 2 minus y. So let's call this particular distance some at any point x. This distance will be y, right? And then the radius of the disk is just everything root 2 minus y. This will be the radius. So because we want this radius in terms of x, let's write it as root 2 minus 10x times sec x, right? So this will be our radius. So what is the area of the slice? So this area of the slice, let's call it ax. This is pi, and you have radius square. So root 2 minus 10x sec x whole square. This will be our area. And now we can find the volume because we have all the information. We have area and lower and upper limits of integration also. So the volume of the solid, this is just integral from 0 to pi by 4 of ax, integration with respect to x. Okay. That means we have to find this integral. Let's call this volume to be v. Okay. So v is equal to from 0 to pi by 2. What is ax? Okay, it's pi by 4. This is pi times root 2 minus 10x sec x whole square dx. Let's take pi outside, and then we have 0 to pi by 4. Let's do a square. So after squaring, you get a 2. You get sec square x into 10 square x, and then minus 2 root 2 10x times sec x. So we have to integrate these functions. Okay. So let's divide this integral into three parts. So 2 dx, and then plus integral from again 0 to pi by 4 sec square x tan square x dx, and then 0 to pi by 4 tan x sec x dx. Okay, so now we have to find these three integral, and this first integral is very easy. You can easily write this integral. Okay, so let's calculate all these three integral one by one. So 0 to pi by 4 twice dx. Okay, so this is just 2 times pi by 4, which will give you pi by 2. Now let's calculate the last integral first, but that is also looks like easy because we know what is the integral of tan x sec x, right? So what is the integral of tan x sec x? Because the derivative of sec x is, so what is the derivative of sec x? It is sec x into tan x, right? Or is there a minus sign? So I don't think there is a minus sign. So I think we can
I
directly
think it's
find out.
10, sir.
It is sec x, right?
Yes, sir, yes, sir.
Okay, so sec x, and you take the limits from 0 to pi by 4. So at pi by 4, sec x will give you root 2, and at 0 it will give you 1, right? 1 over cos. Okay, it's 1. Now we have to find the third integral. So what is the third integral? It's 0 to again pi by 4 sec square x, and then tan square x dx. Now to find this integral, you can do a change of variable. Okay, so what are the change of variable? You can see that the derivative of tan x, right? So what is the derivative of tan x? It is sec square x, right? So if you put tan x equal to some new variable t, then you get this differentiable, that sec square x dx must be dt, and your x was varying between pi by 4 and 0. So what are the limits of tan x? This vary from 0 to 1. That means your t varies from 0 to 1, right? That's how you can change this integral. Now put the sec square x dx, this will just become dt, and tan will become t. So you have t squared dt, and integral is from 0 to 1. Now this can be easily calculated because t square, its integral is t cube by 3, and limits are from 0 to 1. You get 1 by 3. Okay, so now we have all these values of the integral. So now the volume we can find out. So pi was outside, and then integral of 2, that was giving us pi by 2, and plus the second integral, which is 1 by 3, and the last integral is difference of 2 root 2 times root 2 minus 1. So outside a negative sign, then we have 2 root 2, and inside we have root 2 minus 1. Let's simplify this. We have pi outside, then pi by 2 plus 1 by 3 and minus 4 and plus 2. Okay, so let's simplify it further. What can we do? We can take 6 LCM. So outside we can take pi by 6, and then inside we can have 3 pi, then 12 times root 2, and minus 22, right? Pi by 6, 3 pi. Okay, so we can, yes, 3 pi, 12 root 2, minus 22. I think so. The first option is correct here. So we got the volume. Okay. So any question? Okay. So if there are no questions, let's move to the next one. Okay. So this is the fifth problem, and here again you have to find the volume of a solid which you get after you revolve some region. Okay. So we will find this region. Oh, basically, this region is given. Okay. Let me draw this region, and we are revolving this region about y equal to minus 1. Okay. So this region is bounded by this curve y equal to x square and the line y equal to 1. Okay, so what is the line y equal to 1? This is the line y equal to 1, and then this y equal to x square, this is, we know very well, this curve is the parabola, right? So D with the region bounded by the curve y equal to x square and the line y equal to 1. Okay, so there is no condition restriction that we should be in the first quadrant. That means there is a second part also in the second quadrant. Yes. So this is the whole region D. This is our region D, and now we are rotating this region about the line y equal to minus 1, and because of that we are getting some solid. Okay, so now you can see that this region touches this line y equal to 0, and we are not rotating it about that line, right? If you rotate this region about y equal to 0, then you get this kind of solid. So it will be kind of, no. Okay, so okay, let me not draw this, I think. Okay, so but the thing is that you are not rotating this region about y equal to 0. Instead you are rotating it about y equal to minus 1. Okay, so if you rotate like this, then you will always have this gap, this much gap in between. Okay, so the solid whatever solid you will get, the solid will have a hole. Okay, so it is like this. So if you have, I'll give you another example, simple example. Let's say you have a region like this, a square, and now you are rotating this square about this line, which is we write as x equal to 0 or y axis. Okay, so if you rotate this region about y equal to y axis, this particular square, then you will see that this you can obtain in the two ways. So once you can consider this particular, so the idea is you will get a cylinder, but the cylinder will be hollow. Okay, so it will like this. and in between there will be a hole. Okay, so if you see it from the top, it will look like this. Okay, like this. So here you have a hole. Okay, that's why if you take slices, you will get this kind of disc with holes. So these are called annulus. Okay, and now we have to find the area of these slices. Okay, so we are rotating this. These are point 1 comma 1, and this will be point minus 1 comma 1, and we are rotating this region about line y equal to minus 1, so that if you take the slices you will get these kind of annulus disc. Okay, so to find the area of this annulus, you can find the area of whole disc and then subtract the area of inner disc, right? So there will be two radius. One we call it outer radius. So this will be outer radius, and then this there is a inner radius. Okay. Now this kind of area of annulus, this is also called a Wasser. Okay. So if the outer radius is capital R and inside radius is small r, then the area you will get, just find the area of the whole disk without the hole, and now subtract the area which is the area of the hole, okay, inside. So like this. Okay, so this will give you area of the annulus. Okay, so here also the slices, if you take with, so the slice you will take perpendicular to the axis of the revolution, and that axis is y equal to minus 1. So when you take slices about this axis, okay, like this, so you will get a disk. But now you can see that the outer radius of this disk will be the this length. Okay, so this length will give you the outer radius. Okay, so everywhere the outer radius will always be equal to 2, right? This is the length between this line y equal to 1 and y equal to minus 1, it will be 2. So what will the inner radius? So inner radius, you can see that inner radius will, this will be the inner radius. Okay, this length. Okay, so how do we get the inner radius? Okay, so at this distance x, let's call this distance to be x. This length, this particular length is y, and this particular length is 1. Okay, so the outer radius is 1 plus y. No, the inner radius is 1 plus y. Okay, so let me write. So in this case, slice will be an annulus, and its outer radius of this, let's call this slice, this is constant. This is equal to 2, right? Case is not constant. So what is the inner radius? Inner radius is 1 plus y, where y is positive, and this y as a function of x is given by x square, right? Because the curve is parabola, which is y equal to x square. And now you can calculate the area of slice. What is the area of slice? Let's call it again ax. It will be pi, the outer area, or the outer radius, so pi r square, that is outer radius, which will be 4, and then subtract the square of 1 plus whole square. So this will be our area. And now the volume of solid equal to, let's call it again V. Okay, so the volume will be, you integrate everything with respect to x. Now you have to find the limits of the integration. Okay, so now you can see that your slices, they can vary all these this distance, right? So this is just x equal to -1, and here you have x equal to 1. So your limits are from -1 to 1. Now to get this volume, you have to just integrate. Okay, let's write v as integration from -1 to 1. Let's write pi outside in the bracket. Okay, let's take the square of everything. So we have 4, and then we have a square of 1 plus x square, and that will give you -1 minus x to the power 4 and minus twice of x square dx. Again, this is equal to integral from -1 to 1. Now 4 minus 1 will give you 3. So this is 3 minus x to the power 4 minus twice of x square dx. Okay. Now this is the easy integral. You can break it in 3 parts, or you can directly find this integral, which will be 3x minus x to the power 5 by 5 and minus x cube by 3. Okay. And we can also notice that this is a even function, right? So if you replace x by minus x, the function will remain same. So it's an even function. So whenever you have an even function, you can take limits from 0 to 1 and take 2 times twice, right? Because the integrand is a even function. And now these are the limits. So 2 pi times the volume will be 2 pi times 3 minus 1 by 5 minus 2 by 3. So what is this? You can see that we can take this 45 minus, so we can take 15 as outside as LCM, and then we'll have 45 minus 3 minus 10. So 35 minus 3 is 32. So we have 64 pi divided by 15. Okay, so here we have our answer. The second option is correct. Okay, so any questions?
No, sir.
Okay, so let's move to the next problem then. Okay, so this is our fifth problem. So here again we have to find the volume of some solid again, but then we have to minimize it. Okay, so you can see that the region here is just given that the curve is sin x. Okay, so sin x between 0 to pi. So this is the line when x is 0, and then there will be line x equal to pi. And between this there is a region, and the region is given by this curve, which is y equal to sin x. Okay, so and this okay, so we are revolving this curve about the line y equal to c. Okay, so this is y equal to c. So c is some constant number, y equal to c. C varies between 1 and 0. Okay, So line can be x-axis or the line can be this line, just which just touches the curve. That is y equal to 1 here. Right. This line can be anything, and according to this line, you have this region. The region bounded like this. Okay, so you can see that because your limits of x are from 0 to pi, right? So there is a small region inside this also, this here, because this line varies, right? This line can be anywhere. Okay, so if you take a different line, is let's say C1 and C2, then your region will be just this. The region bounded by the function sin x and this line. So this will be your region, and then inside also you have something. Okay, like this. And now you have to rotate it about the line y equal to c, and then you will get some volume. Okay, you get some solid and you have to find its volume, and you have to find the value of c at which the solid is minimized, the volume is minimized, and what will be the minimum volume. Okay, so it's the optimization kind of problem. Okay, so what is the aim? So it's the optimization problem. So these kind of problem are called optimization problem because we have to find the some optimal value, maxima or minima. Okay, so what is our goal or our aim? To find the value of c which lies between 0 and 1 and the minimum volume. Okay, so the minimum volume of solid given by revolving a region, let's call D, about a line y equal to c. Okay, so about this line we are revolving, and we have to minimize this volume. So now to minimize the volume, first we have to find the volume, right? So now we will find this volume as a function of c, because here this c is our variable. Okay, so to find this volume, again we have to use the slice method, and because these lines of revolution they are parallel to x-axis, so you have to take slices which are parallel to the slices which are perpendicular to the axis of revolution, right? The axis of revolution are these y equal to constant lines. Okay, so that means you have to take these kind of planes, and these planes will give you some slice because they intersect your solid. Okay, so they intersect your solid at and gives you a disk, and you have to find the radius of that disk to get the your volume, right? So what will be the radius of this disk? Right, so any arbitrary point, let's say you are at a distance of x from here, and at this particular distance you can see that if you are on this curve, now this curve is the sin x function, right? On this curve, this whole distance, okay, so if this is your x, then this whole distance is just y. Okay, but you want to find just this distance because this will give you the disk, the area of the disk. Okay, let's see that if you are, this is your disk, and this is the line which is y equal to constant. Okay, so this will be your radius. Okay, so to find this radius, what you have to do, you have to subtract c from the y, right? Because this everything is y, and this thing is c. That means the radius of slice is equal to, so what is this c? This thing, this is y minus this c constant. But y as a function, let's call it r time r as a function of x, it is just sin x minus this constant c. Now, but we note that this constant c can be anything, right? Because c varies between 0 and 1, and because of that, the difference sin x minus c can be either less than 0 or greater than 0, right? You can see that why this is the case, because c lies between 0 and 1, and sin x function, this also lies between 0 and 1, but because x varies from 0 to pi, right, this also lies between 0 and 1, but since x varies from 0 to pi, your sin x first increases to 1 from 0 to pi by 2, and then decreases to again 0, right, between pi by 2 and pi. That means we don't know if sin x is negative, sin x is less than 1, or sin x is greater than 1, right? It can be anything, because your line can be this higher one, line y equal to c2, and then your sin x, your distance x may be very large, like this, up to this point. Okay, so this and the radius, now radius of the slice will be this much in between whatever left. Okay, so therefore you have to put a modulus, because we want to find its length, right? Length cannot be negative, and now we don't know if sin x is less than c or greater than c. Okay, so what is the area of the disk? Now we have the radius, area of slice, this is pi times the rx whole square, right? So pi sin x minus c. So initially there will be a modulus. Now then you square it. But since the square always gives you positive function, so you can remove the modulus, right? The modulus of x square is same as x square, okay? Or you can write it at the square of minus x. So anything. That's why this will be the area of the slice, and now you can find the volume. So volume of slice, no, the volume of solid, not slice. Okay, so this time we write v as a function of c, because the c is unknown. Okay, so it is constant, but it is not known. C varies between 0 and 1. Okay, so we have pi, and then we have sine of x minus c whole square and dx. Okay, so x varies between, so where does x varies? X varies between 0 and pi, right? This is 0 and pi. So let's find out this volume. So pi we can take outside. Oh no, so I think there is a problem with my device now. Okay, okay, let's wait for 2 minutes. So there's a problem with my writing device. Just wait for 1 minute. Okay, so I was here at this point. Okay, so the area we get this volume. So just take the square. So you get sine square x plus c square, and then we have minus twice of c times sine x, right?
So your screen is not sharing, sir.
Okay, okay. So because of this, the previous problem, I closed my this particular window and I opened a new one. That's why. What's the problem? So now it's visible, right?
Yes, yes, now it's there, sir.
Okay. So now it's not very difficult to find this integral, right? You can break it into three parts. Only this sine square integral, this we have to find. It will take some time, not much, but just break into three parts: c square dx, and then twice of c outside. Then we have sine x dx, again from 0 to pi, like this. So okay, so let's calculate all the integrals. So the easiest one is 0 to pi is just c square dx. It will give you c square pi. Then you have a integral of sin x dx, again 0 to pi. So this integral is minus cos x. Then you can put the lower and upper limits from 0 to pi. You will get 1 plus 1, which is 2. Now the last integral is has sine square as integrand. So if you don't have this power, the square of sine, then it will be easier to integrate. So that's why we'll use some cosine half angle formulas, right? So this it is so what is cos 2x? So it is 1 minus twice of sine square x. So you have 1 minus cos 2x divided by 2. So this will be equal to sine square x, right? Yes. Okay. And now you integrate this from 0 to pi. So again, this can be split into two parts. So the first part will give you just pi by 2, and the second part is just integral of cos 2x, again from 0 to pi. So this will give 0, I think. So this will be from 1 by 4, and then you have sine 2x, the upper and lower limit are 0 to pi. Okay, so this will just give you pi by 2, because sine 2x, sine 2 pi is also 0, sine 0 is also 0. So now you have your volume, which depends on c. So v of c is equal to pi is outside. So the first integral was the integral of sine square, which gives you pi by 2. Second integral was c square, so it gives you c square pi. Third integral was twice of c, and the integral, which is 2, so it is minus 4 times c. Okay, so this is your volume as a function of c. Now we want to minimize this volume, right? because our aim was to minimize the volume and find the minimum volume and see where it is minimum. Okay, so for that you have to find the critical points of this equation. So let's write VC like this. It is just pi square by 2 plus pi square c square and minus 4c pi. So we have to find the critical point, and the critical point you get where derivative becomes 0. So to find that, you get 2c pi square minus 4c. This is the derivative, and this becomes 0 if and only if. Okay, so we are differentiating with respect to c, so this c will not be here in the second term. Instead of that, there is a pi. So this will imply that c must be 4 pi divided by 2 pi square, right? That means it is 2 by pi. Okay, so at this point c, which is 2 by pi, volume will either be maximum or minimum. That now we don't know if it will be maximum or minimum, so that we have to find, because 2 by pi is just critical point. So let's use the second derivative test, because it's easy to find the second derivative. So if you find the second derivative, then you have just 2 pi square, right? And this 2 pi square is positive always, because it's a constant function, so it's positive. That means this x equal to, or not x, c equal to 2 over pi. This is a point of minima. So at this particular point, the minimum volume achieved. And what will be the minimum volume? The minimum volume is the volume at c equal to 2 over pi. So this now we can calculate. So this was our volume equation, and this you can calculate easily. Pi square by 2 plus pi square into c square. So c is 2 by pi, so you have 4 by pi square, and then minus 4 pi times c, which is again 2 by pi. So pi square by 2 plus 4 minus 8, this gives us pi square by 2 minus 4. I think let's write it like this. Take half common. You have pi square minus 8 outside half. Okay, so yes, the first option is correct here. Okay, so any questions?
No, sir.
Okay, so no questions, right? Okay, so if no
No, sir.
questions, let's move to the next problem. Okay, so all these problems are kind of similar. You have to find the volumes using the slice method, and mostly the slices will be circular. So circular means they can be either a disk or hollow disk with some hole inside. Okay, so you have to just find the area of the slice and integrate. Okay, so you have to find the volume of solid generated by revolving the region. So what is the region? Let's draw this region. Again, the region bounded by x-axis. So where is our x-axis? This is your x-axis, and and then there is this curve which is y equal to 3 x to the power 4, and then you have two lines. So x equal to 1 and x equal to minus 1. So what is x equal to 1? Let's call this to be x equal to 1. Okay, x equal to 1, and then x equal to minus 1. So these lines and the region bounded by. Okay, so what is the region? This y equal to 3 x to the power 4. Okay, so it will look like parabola. Okay, so it is like this, and the region will be this inside. Okay, because the region is bounded by the curve, so this is your curve, then this is your lines, all the lines, and the x-axis below is the x-axis. Okay, so you have to find the volume of the solid generated by when you revolve this region about x-axis. Okay, so note that we are again revolving this about x-axis, and therefore the solid which you get will look like this. So here we can draw this solid easily, so it will look like this. It looks approximately like this. Okay, so whenever you take a slice, okay, so your axis of revolution is x-axis. That means you have to take a plane and cut this solid with. Okay, so you have to take a plane which is perpendicular to x-axis and cut this solid anywhere, right? You can take this plane also and any other plane. So this plane will cut your solid into some disk. That you have to also always remember. Whenever you are revolving, whenever you the solid you are getting by revolving, you always get a disk at the cross section, right? This will be your disk, and now your volume is just the integral of area of this disk from the lower limit to the upper limit. So this, you can see that this disk can vary between this range, right? X between 1 and -1. So what will be the radius of this disk? So the radius of this disk is this particular distance, which is y. Okay, so the radius of disk, let's write as a function of x. Okay, so it will be equal to y, but as a function of x, it is 3x to the power 4. So what is area of disk? This is pi times 3x to the power 4 whole square. And then what is volume? It is integral from -1 to 1 pi times 3x to the power 4 whole square dx. Now you can see that if you square it, you will get 9 pi outside, and it's a even function. So because of the even function, you can write this integral 2 times of from 0 to 1, right? So x to the power 8 dx. Now this volume is not difficult to find. So what is the volume? V is 18 pi integral from 0 to 1 x to the power 8 dx. So 18 pi times, so the integral will be x to the power 9 by 9, and you have to put upper and lower limits. That will give you 18 pi into 1 by 9. So you get 2 pi. Okay, so the last option is correct. So this was the easier problem. So any questions? Okay, so if no questions, let's move to the next problem. Okay, so in the next problem, I think it's the same region, but we are revolving it about a different axis. Okay, again, so the region is same, I think. So it's bounded by line x equal to 1 and -1. So again, we have these lines x equal to -1, then x equal to 1, and okay. Okay, so this will be again your region, but now we are revolving this region about the line y equal to 3. So there is some line which is y equal to 3. Let's draw it here. Okay. Okay, and your solid touches this line y equal to 1, and now you are revolving this solid about the line y equal to 3. Okay, so now you see that there will be gap by this much. Okay, so whatever solid you get, if you take the cross sections about the planes which are perpendicular to the axis of revolution, which is y equal to 3, you get a disk which will have holes. Okay, uh, so you take some plane which is perpendicular like this. So now you'll have hollow disk like this. Okay, and for this disk, this will be outer radius, this everything, and this is inner radius. So what is the inner radius? This much distance is the inner radius. Let's write r of x as a function, and this is outer radius. It's everything. Let's write capital R of x. Okay. So again, let's write in this case, slices are endless. Okay. With what is inner radius? So inner radius is this Rx is equal to, so what will be the inner radius? So inner radius will be this distance Rx, capital Rx minus this distance, right? Okay, so if you are at a distance x, let's say this is your x, that means this distance is y, and that will give you the outer radius to be. Okay, so what is this capital Rx? Let's first write capital Rx. The capital Rx is just 3, right? Because this distance is 3. This distance is 2. This distance is 1. So capital Rx is 3. And therefore, this small Rx is just 3 minus this y. So what is y? 3 times x to the power 4. Okay. So that's how we get inner and outer radius. So what is the area of this endless, or area of this slice as a function of x? This is just pi outer radius, which is 3, and subtract inner radius. So you get 3 plus 3 times x to the power 4, and then square. So you have again 9 pi x to the power 8. Okay. Okay, so I think this area of the slice is wrong. Okay, so the area of the slice will be outer radius square, this capital R, minus inner radius square, right? We have to first take the square so that we get the area, and then we have to subtract, not the radius. So it will be pi. So what will be the square of 3? It's 9. And then we have 3 minus 3 x to the power 4, this whole square. Okay, so this will be the area. Let's simplify this. You can take 9 outside, so you have 9 pi. Then 1 minus x to the power 4 whole square. 9 pi. Let's calculate it. 1, then minus 1 minus x to the power 8 and plus twice of x to the power 4. This is 9 pi times twice x to the power 4 minus x to the power 8. So what is the volume? Now we can find the volume. So volume of solid is equal to, now you can see that your x is again varies between 1 and minus 1. So your slices are between minus 1 and 1, and then you have ax dx. But what is ax? You have 9 pi outside, right? And you have twice of x to the power 4 minus x to the power 8 integral from minus 1 to 1. And again you can see that this inside is an even function, so you can write 18 pi integral from 0 to 1 twice x to the power 4 minus x to the power 8 dx. So what is this integral? So x to the power 4, the integral is x to the power 5 divided by 5, and this integral is x to the power 9 divided by 9, and then you have to put upper and lower limits. So 0 will give you nothing, and from 1 you get 2 by 5 minus 1 by 9. So let's simplify this. So it is 2 by 5 minus 1 by 9. It is 13 by 45, right? So 26 pi divided by how much? 5. It is 26 pi divided by 5. Second option here. So any questions? Okay, so if no questions, let's move to the next problem. Okay, so the region bounded by the curve in the y-axis. Okay, so again you have to find the volume of a solid that you get after you revolve some region about y-axis. Okay, so this time we are revolving the region about y-axis. So what is that region? Let's draw it. So you can see that y varies between 0 and 1. So this line is y equal to 0. Then we have line y equal to 1. In between we have this curve. So this curve is given as a function, such a tan function. So let's write it like this. So when y is 0, x is 0. When y is equal to 1, so when y is 1, what is x? X is also 1, right? That means this thing is x equal to 1. And the region is bounded by the curve and the y-axis. Okay, so this is your region. Okay, and this region is revolved about the y-axis. So this is your y-axis. So if you revolve this region about y-axis, you get again some hemispherical ball. This kind of like this, right? This kind of ball you get. You have to find the volume of this region, this solid. Okay, so if you take cross section about the planes which are perpendicular to your axis of revolution, which is y-axis, This perpendicular plane will cut your solid into disk, right? Like this. Okay. So what will be the area of this disk? Okay. So in this case, your area. So the area will depend what is the radius. So the radius is this distance. The distance is given in terms of x, but you can see that your limits of integration are in terms of y, right? Because this slice can vary between this axis y equal to 0 and y equal to 1. So your y varies lies between 0 and 1. Okay. So what is your radius of slice, which is actually x, but as a function of y, right? Because we want to write it as a function of y, where if you write it as a function of y, then it is just 10 pi by 4y. Okay. So this is the radius, and then you can find now area of slice ax. It is just pi radius square, so it's a 10 square pi by 4y. Okay. So what is volume? Integrate your volume of or area of the slice from 0 to 1. So what is the integral of 10 square?
You can take.
What is?
No, 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 no. Sorry, sorry.
Okay, so we can use some trigonometric identities, right? Because we know the integral of sec square, and then we have this kind of relation that sec square x minus tan square x is equal to 1, right? So this thing we can write it as 0 to 1 pi in the bracket sec square pi y by 4 minus 1 dy. Now it's not that difficult. So you can integrate sec square. So let's take pi outside. But you also know that if you have some constant in the variable, then that constant must be divided. The integral of sec square is just 10 square. It will be 10 square pi y by 4, right? Now you have to also divide by the constant which you have as a multiplication in the variable, and that constant is pi by 4. So you have to divide it by pi by 4. So you get 4 by pi, and then you have to take upper and lower limit which are from 0 to 1. Okay, so why we are dividing it by this factor? Because of the chain rule, right? Because in the chain rule, if you differentiate this function again, okay, so integral of sec square is just 10, not square. So if you just now again integrate it, so this pi by 4 will come outside because of the chain rule, and that will cancel by this 4 over pi. Okay, and minus just y, and y also has limit from 0 to 1. Okay, so now like write final volume v, which is pi, and 4 pi by pi times 4 by pi we can take common. So if you put upper limit which is 1, so you'll get 10 pi by 4, which is also 1, and then lower limit is 0, so this 1 minus 0, and then again from y you also get 1. Okay, so pi, in the bracket you have 4 pi minus 1, that is equal to 4 minus pi. Okay, so 4 minus pi is the final answer. Okay, so any questions?
No, sir.
Okay, so no questions. So let's move to next problem. Again, these are same kind of problems. You have to find volume of the solid which you get after revolving some region. So let's see what is the region. So here this region is bounded by some curve, and that curve is given by this y, which is sin x times cos x. So if you see, this is really half of sin 2x, right? It's equal to this. So it's a sine function basically, and it says that the region is bounded by this curve and line segment joining these 2 points. So what are these 2 points? So 0, 0 is just the origin, and pi by 2 0 can be here, thought to be here. This is pi by 2 comma 0. This is 0 comma 0. Okay, and you will see that the curve will join these 2 points, right? Because this curve is just half of sine 2x. So if you put x equal to 0, you will get 0. But if you put x equal to pi by 2, then you will get again 0. But what about pi by 4, the highest point? So at pi by 4, you will have half. So this highest point is just half. So this is half. And now you are revolving this region D about x-axis. Okay. So if you revolve this region about x-axis, you will get something which look like a sphere, but it may not be completely a sphere. Okay. So it can be some ellipsoid kind of thing. Okay, like this. So the cross section will be disk, right? About again, the cross section will be disk. So these are cross sections, and this is your solid. Okay, so to find again the volume, you have to find the area of these cross sections. So for that, you have to find the radius. So radius will be this much. This distance is your radius. So which is radius of slice? So radius of slice is y, which is half of sine of 2x as a function of x, right? Let's assume that we are at a distance of x. So now you have the radius. From that you can get area of slice as a function of x is given by pi times the radius square. So pi by 4 sine square 2x. Okay. So now because we have to integrate this, the sine square we will convert it to 1 minus cos of 4x divided by 2. Okay, so we can write it like this. So what is volume? So volume of solid, which is, let's write V, that is from 0 to pi by 2. So now your x varies from 0 to pi by 2. It's pi by 8. In the bracket you have 1 minus cos 4x dx. Okay, so pi by 8 outside, you can take it outside, and then you have integral to be x minus sine 4x and divide by 1 by 4. This you have to take limit from 0 to pi by 2. Okay, so again you can see that the sine 4 times x will give you nothing because limits are from 0 to pi by 2, and at both of these upper and lower limits sine will become 0. So the volume of the solid will be pi square by 60. Okay, so this here second option is correct. Okay, so I think now am left with this last problem, and we have only 2 minutes. So let's finish this last problem. Okay. So again, you have a solid that is generated by revolving some region about x-axis. Okay, so the axis is x about which we are revolving, and the region is bounded by the graph of some positive function. Okay, this function we don't know, but we know that this function is positive. Okay, and there are two lines. So let's say x equal to a, and then there is a line x equal to b, and this function will have some graph. Let's say this is the function y equal to fx. So This is the curve or the graph of the function, and the region is like this. So the region is bounded by x-axis. This is x-axis, and line x equal to a, x equal to b. Okay, and the function is positive. That's why we are drawing it above the x-axis. And this is your region, and this region now you are rotating about x-axis. Okay, so if you rotate it about x-axis, you will get again some solid. That solid will have like this. The base. These base will be circular and like this, and the cross sections they are also disc. Okay, so this to find the volume you have to find the radius. So what is the radius? Radius is this vertical distance. So what is this vertical distance? This depends on how much distance you are at, right? Let's say you are at distance x, then this will be y, which is fx. Okay, so the radius is fx. So it's the same thing. Let's write volume directly. So what is the volume? V. This is integral from a to b pi and then fx whole square. Okay, so this will be area pi times the radius square. Then you are integrating it from a to b where a is less than b. Now it is given that this volume is equal to b square minus ab. Okay, so the volume is given. Okay, now given that v is equal to b square minus ab. Okay, so that is this integral from a to b pi fx whole square dx is given to be b square minus ab. And now note that in the problem it is written that line y x equal to a is fixed. It's a fixed line, and line x equal to b is a variable. Okay, so b can vary, but x is fixed. The a is fixed, b can vary. So instead of this b, we can what we can write. Okay, so since okay, so so this equation holds for every b greater than a. Okay, so this implies that we can replace this b by some variable. Let's not call it x, let's write it t, and then we have pi fx whole square dx to be equal to, so instead of b we are writing t, so t square minus at, right? Okay, now in the problem is asked you to find the function fx. So what is the fx? Okay, this fx we have to find. The volume is given. Now we will use the fundamental theorem of calculus. Now, from the fundamental theorem, integral calculus, if you differentiate both sides, then what do we get? Differentiate with respect to t from a to t pi fx whole square dx. Here also d by dt of t square minus at. Okay, so this you can do. This will give you, okay, so the left hand side will just become pi times f of t whole square. Okay, because now it's a function of t. So f of t whole square. And on the right hand side, you have twice of t minus a. Now it's easy to find f of t, right? Why? Because you just divide by pi and take the square root. So 1 over root pi 2t minus a square root, and it's plus minus. Okay. Now it's given that function is positive, so you don't have to take the sign. It's a positive square root. Okay, so what is f of x? It is just equal to 2x minus a square root divided by root pi. Okay, so here is given plus minus. Okay, so you don't have to take plus minus because it's given that function is positive. So all these options plus minus you can remove, but the right answer is the first one. Okay, because okay, so first is the right answer. Okay, so we have finished solving all the problems, and now time is also over, so we stop here. Thanks everyone for joining. So I'll meet you next week with a different set of problems. So till now, let's sign off.
Thank you, sir.
Okay.